Today we're talking about exponential growth and decay word problems. So we've only got a couple of examples here, but let's kind of review exponential growth and decay functions first. So if I have an exponential growth function or decay, if I have an exponential function, the basic setup is that f of x equals a times b to the x power. Now, it doesn't have to be f of x. You could put a y here instead, or you can change the name of the function to something else. But it's going to be a times b to the x power. And your a is always going to be your starting value. So anytime you're looking at a word problem, look for that starting value. That's your a. Okay? This is going to be your y-intercept. If you're looking at a table, find where your x is 0. That's your a value. The b value is your factor. This is either going to be your growth factor or your decay factor. Which one it is depends on what the value of b is. Okay. Now, another way that we can look at b is when we have a rate. Okay. So if I have f of x equals a times 1 plus the rate to the x power, this whole thing is my b. Okay. This specific 1 plus r is a growth function. And when it is f of x equals a times 1 minus r to the x power, this is a decay function. And again, the 1 minus r, this whole thing inside the parentheses is our b value. Okay, so you've got your rate and then your factor. Your rate is part of your factor. It's either 1 plus the rate to make your factor or 1 minus rate to make your factor. Okay, and then we can use that function, that setup, to write an equation to try and find a value somewhere else further down the line. Okay, so let's look at a couple of problems here. Let's start with a population of 800 beetles that's growing each month at a rate of 5%. And how many beetles are there in 5 months? All right. So the first thing that we want to do is identify our rate and our factor. Okay. So find our rate and factor. Okay, so we have a rate of 5% and it's growing. So this is going to be a 1 plus. Okay, because it's growing, this is going to be a 1 plus the rate. Okay, so my rate is 5%, which we're going to have to convert to a decimal. So that's going to be 0.05 because we moved the decimal 2 places to get to that. So our factor is going to be 1 plus 0.05 or 1.05. Okay. Next, after we find our rate and our factor, we need to find our y-intercept. Okay, we need to find that starting value. Okay, so our y-intercept, our starting value is 800 beetles. All right, so our A is going to equal 800. Now we can write our function. Okay, so when I write my function, you know what? I'm going to use variables that actually have to do with our situation. So we're going to talk about beetles with respect to months. So our beetles, we're going to write our function. So we're going to use beetles. B for beetles, M for months. Okay. Equals. We're going to do our A value is 800 times our 1 plus our rate, so our factor being 1.05, okay, to the x power. So now let's answer the question. Oops. All right. We're going to answer the question. So to do that, we're just going to plug the 5 into our x. So B times, or excuse me, B of 5, or B with respect to 5, is 800 times 1.05 to the 5th power. Okay. If you can't do this math in your head, don't worry. Nobody expects you to. You could just use a calculator. So I'm going to use my TI-84. We're going to do 800 times 1.05 to the 5th power. And we are going to get a value of 1021.02525. Okay. Now, we kind of have to use some common sense here. We cannot have part of a beetle. Okay. Even those of us that don't like bugs and we'd rather see them, not whole. When we're talking about a population of beetles growing, we can't talk about having part of a beetle. So we're going to round this to the nearest whole number. So the nearest whole number is going to be 1021. Okay. So 1021 beetles. Now, depending on the situation, you may have to round up, you may have to round down. Okay. 5 months, we will have 1021 beetles. Had that partial decimal value been a little bit bigger, we would have said 1022 beetles. We want to round it to the nearest whole number in this case. Okay. So there's our growth function. And once you identify your rate, add that to 1. That gives you your factor that you can use in your equation. Okay. Now let's look at a decay function. Our decay function is going to be similar. Okay. We're still going to find our A value. Okay. So this is our starting value. We need to look at which way it's going. So in this case, it depreciates. We have a new computer. It costs $1,500, but it depreciates in value by about 18% each year. So approximately how much to the nearest penny will your computer be worth in 3 years? Okay. So depreciates means it goes down in value. By about 18% each year. All right. So for our first step where we have to find the rate and factor, Okay. In this case, our rate is at 18% or 0.18. Because it depreciates, that means we're going to do a 1 minus the rate. So for our factor, we're going to have 1 minus 0.18. So when we subtract 0.18 from one whole, we're going to get 0.82. Okay, that's how much of the value it retains, how much of the value it keeps each year. So next we need to find our starting value. Okay, find the start value or the Y-intercept. Those are going to be the same thing. So in this case, our A is going to equal 1,500. And then we can write our equation. All right. And again, I want to use variables that have meaning to the problem. I could just use X and Y. That's fine. It doesn't matter. Use the variables that are going to help you understand the problem. Okay. So I'm going to use value, V for value. And well, I don't really want to use Y because that might get confusing. So I'm going to use T instead of years or for years. So we're going to use the value with respect to time is 1,500 times, we're going to put our rate, or excuse me, our factor in there. And the factor, remember, is 0.82. Okay, we did the 1 minus 0.18 to get the 0.82. All right, and then let's answer our question. Answer the question. All right, so the question is, what is the value of the computer in 3 years? So time is 3. So 1,500 times 0.82 to the third power. Again, don't expect you to do this math in your head. You pull up whatever calculator you have. You can use a simple 4-function calculator. Okay. Sorry, guys. My computer is going a little nuts out here. You can use a simple 4-function calculator if you want to. If I can pull mine up, I will. My screen is going a little nuts. So, all right. It's not letting me pull it up. You can pull up your simple 4-function calculator. You can use, I use a TI-84 in my classroom. It's fine. Most of your, well, if you use a 4-function calculator, you're going to have to multiply by 0.82 3 times. Most of your calculators on the computer or even on your phone have an option to change them to a scientific calculator. Use that. Okay. So that way you have the exponent option to it. So when we do 1,500 times 0.82 to the third power, we're going to get $827.05. Okay. So $827.05. Now it actually will, when you put it in the calculator, whichever calculator you use, it actually comes out to 827.052. But it did tell us to round to the nearest penny. So our nearest penny would be 5 cents. All right, that is our exponential growth and decay word problems, you're looking for 2 pieces of information, and that's going to help you solve your equation. Okay. If you have any questions, you know how to get a hold of me. Just shoot me a message and I will be happy to answer your questions. Guys, y'all have a good day, and I will talk to you later. Bye-bye.